Good afternoon, my name is Heru Foriat. I'm the Senior Vice President for Ocean Thermal Energy Corporation dealing with the Caribbean and Africa. And we are here right now in St. Croix. We're doing a site visit for feasibility study for the Virgin Islands Legislature to see the applicability of ocean thermal energy technology for the Virgin Islands. And we are here with our Chief of OTEC Operations, Dr. Ted Johnson, and we are here with our friends from France with DCNS as well, and I'll allow them to introduce themselves.
Yeah, look, I am the Vice President for Partnership and very keen with DCNS and OTEC to develop that project in Virgin Islands.
And I'm Frederick from DCNS, also working as a sales manager for OTEC Technologies.
Okay, let me explain briefly what we're trying to do here on St. Croix. We've identified three what we believe are key sites for an OTEC plant. One of these being at Salt River, where we are today. You can see we've laid out a hypothetical location for the plant. And now we'll be taking a survey along the shore here to check the conditions to build an OTEC plant, and then we will go to several other locations on St. Croix after that. Okay, so we'll be walking down here first to take a look at those conditions. So what we're doing now is taking a video along the shoreline here to get an idea of the shore conditions. And if you look out to the sea out there, you can see the quick change in color to a very dark blue. That is a very steep drop-off that we need for cold water for OTEC to operate efficiently. So there's ideal conditions in this part of St. Croix to do that. And now we're going to pan a little to the left here, to the west. Let's take a shot down there against this outcropping of rock. So our OTEC plant would be anywhere beyond that next outcropping of rock, depending on land availability, which would be part of the assessment study. Land could be available to build the plant. So now what we'll do is we will walk back to where we started, and we will go east toward the inlet, toward the bay of Salt River, and take videos from that part also, because also across from that bay would be ideal locations for our OTEC plant. Okay, now we're east of the location where we just filmed, and now looking east toward the mouth of the Salt River Bay. So the two locations will either be west or east of Salt River Bay. So we're going to take a quick shot of that and use that for our analysis purposes.
Here we are at Salt River, and this is the backdrop as to where the locations would be that would be really favorable for an OTEC plant.
Yes, this is one of the candidate locations we'll be analyzing in the feasibility study. And if I can show you this map here for just a second, you can see we've located a hypothetical location here in the Salt River area. The reason we're here is the water drops off very quickly to very cold water, which is a requirement for an efficient OTEC plant. So we've mapped the video basically from the eastern side here, progressing east now to Salt River Bay. And if you look out at this point over here, where the land gets flatter, and there's no housing, that would be a candidate that we will now analyze for OTEC, as well as the initial video, which was the western side as we walked along. Okay, we're now at the Rustop Twist area, again on the north side of St. Croix. This area is west of the Salt River site that we were at before. If you look at the water out here, it has a very steep drop-off to much colder, deeper water that you can see from the different colors of blue out here. So what we're going to do now is take a look at the shoreline. You can pan over that way. Here at Rustop Twist, and do a survey of that. And then, okay, now we're panning over here. This is to the east. You can see the land is quite flat here, which is good. Got good wave action. So this would also be ideal for a submerged OTEC plant close into the shore, but beyond the coral and the other elements of the sea, basically submerged so it couldn't be seen. And then we would tunnel underneath there all of the places between here and the shore, and then again bury the pipe on shore for a while. If we had a system on stilts, then we would simply have an electrical cable that would be buried here at some point on the shore. So we're out here today doing that survey, and things look very encouraging to start our feasibility study, which will analyze these locations, plus another one here on St. Croix called Butler Bay, to precisely put all the parameters so we can determine how much power we would get out of the OTEC plant and so forth. And of course, one advantage of OTEC, it's totally clean. There's no carbon emissions of any kind. It utilizes the sea. It has no external fuel other than that, so the fuel is free. So you would have energy dependence in the USVI simply by using OTEC. It can also generate clean water, which is a big advantage also. And so no longer would you be dependent on foreign sources of fossil fuel, but simply use the sea. We're not changing the chemical composition. We just take the hot water at the surface and the cold water at the bottom and put it through essentially with a heat pump, which is like a refrigerator, same technology. We just reverse the process. And so it takes energy then out of the hot water at the surface, as long as we have the cold water, which we do here. And it barely changes the temperature of the water, initially just like a degree or two, but then we mix it with the cold water, so there's no impact at all on the ocean or the sea creatures, which we keep out with various screens and so forth. So we really believe OTEC is ideal for the U.S. Virgin Islands. It will significantly lower your cost of electricity, which will allow competitive manufacturing. And instead of paying all of that money that you presently pay for fossil fuel to somebody else off island, we can use that money to provide jobs here to actually build the OTEC plants. Thank you. So I got my little scoop.